Huh? What is this? The level continues to the right? I wonder what's over there. Oh hell no. What is going on, my fellow aspiring game developers? I hope you're doing well. Today we will add the ability to have bigger levels, or in our case, longer levels in the x-axis. We're not gonna make our level bigger in height, so we're just gonna care about left and right. This is a must for most platformer games, and I will explain and show how I add this feature. So stick around, subscribe and like the video, and then we can begin. And as always, a quick recap from the last episode. We finally added our pause screen. We started with some good looking background, and with this background in place, we could start adding the buttons. First we had the music and sound effect buttons that toggled on and off. The second type, the URM buttons that we called it, that allow us to replay, unpause the game and also go back to the menu when pressed. And the last one, the slider, were the one that required the most work in order for it to work. Here we had to update the hitbox after the use, as well as setting two stops, one on the left and one on the right, so we didn't go off the slider. And that, my friends, are the last episode in short. Now, let's talk about how we will add this level shift function. As I mentioned before, we will add something that will move our level. I'm not sure what it's called, I don't think it even has a name, but whatever. The TLDR version is that the level will move if the player is close enough to the edge of the level, granted that their level is bigger than the actual window size. So how will this be done? How will we code this? When the player is far enough to the right, we will have to set this ourselves. But for this example, let's say 80% of the game width, in this case 80 pixels. When the player passes this border, any pixels beyond this line will be the amount of pixels we need to move the level to the left, and also the player. Let's say the player is past the border at 85 pixels, meaning 5 pixels over the line. Those 5 pixels will be added to an offset variable, and we will have to move everything in the world by 5 pixels to the left. Currently we just have the player and the level. But going over each object, the player, the level, and telling it to change the position is bad practice. It will work, of course, but that would lead to all sorts of issues with hitbox collisions and such. Is there a simpler and faster way to do this? Yes there is. And that is to keep the position for everything as is. But we change how we draw it. We simply add an extra variable to everything in the draw call that takes in the offset. So the player still have a position that is 85, but when we draw it, we go 85 minus the offset. So it looks like the player is at 80. That way, when we later check for collisions, etc., it will still work without having us to change all those methods. And that is pretty much how we're going to do it. So let's do it. Alright, before we start coding, we are going to need a new level image. And I'm gonna take this one. It's the same one as we have, but I just copy-pasted the corner and dragged it. So this will now be our level, and the level name will be level 1 data, but underscore long. So let's just drag that into our res folder. Okay, so we can see here we have level 1 data long and level 1 data. So we're gonna use the long one. And you can find this on GitHub or on my website. But into our load and save, where we have the level 1 data, we're gonna copy this line for the level data and paste it underneath, but comment out the old one. And here we're simply going to add long. And as we can see, we still have the same name, but the image we're using is different. So that's good enough here. There is one more thing we need to change in our load and save, and it's this level data array. When we load the image, we're using the size of the image to loop through each pixel and add those pixels into our level data. But currently, this level data size is tied to the values we set in our game class. And these values right here in our game class will be the visible tiles, not the total tiles. So we're not going to change anything here. We're just going to think of these as the visible tiles. So we're going to see 26 tiles in width and 14 in height. That's our game screen size. So we're not going to touch this. This is good. We just need to keep that in mind, that this is the visible size and not the actual size of the level. So we're gonna do a switcheroo. We're gonna remove that and place it underneath here. And instead of the game width tiles in height, we're gonna go with the image.get height, and then of course image.get width. So now our level data will be the same size as the image, which is the level. And that's all we need to change in here. So we can save it and close it down. And the second place we need to change in our code before we can start actually the feature of this moving the level is in here for our isSolid. What we're checking here is that we're making sure that the player is inside the window, currently at least. We're making sure that the x is not less than 0 and the x is not more than the width of the game. If that's the case, then it's hitting the wall, so return true. It is solid, we can't go there. But our player x is gonna increase more than the game.width, because this game.width is also tied to the visible size of the game. So this one we need to change up. And we're only going to change this line here. But we don't know how big the actual level is. We only know how big the visible is. So somehow we need to know how big is this level actually. How big is the width in this level? And we're gonna get that from our level data variable that we already have here. So we don't have to add too much, we just need to add one line, which is int max width, which is the max width of the entire level, is equal to level data 0. We're just gonna pick the first one, dot length. So now we're getting the length in width times game dot tiles size. So we know how big a tile is, and now we get the actual width in pixels from the level, and those two becomes the actual max width. And then just take this max width and place it in here instead of our game width. So now we have the max width, and if we're within these bounds, then it's okay. We can check whether or not there is a walkable tile there or not. So if we try it now, it should start. It did. And let's just run here. So as you can see, the player disappears. He can actually walk over here because the tiles here are walkable. So now we just need to make sure that the level moves and the player moves when we are close to the edge. And surprisingly, this feature of adding the level move and player move is not that difficult. We just need to keep track of a few variables, and if the player is beyond the border, then we take the difference between the player and the border and apply it to the offset, so that the next update the player will, well, he will still be in the same position, but everything else looks a little bit further to the left or to the right. So up here we're gonna add a couple variables in our playing class. We will need a private int. We're gonna use integers. The actual x level offset, meaning this is the offset that we're gonna add to and remove from to draw everything a bit to the left or to the right. And we will need a private int left border, and this left border will simply be the line which, if the player is beyond, then we're gonna start calculating if there is anything to move. So the left border is equal to recast to int. Let's just say 20% of the game.game width, meaning if the width was 100 pixels, then if the player is below 20 pixels, we need to move the level to the left. So that's just something you can change yourself, but I think 20% is a good in either direction. And just like the left border, we need a for right border. And we will do the same here. Just copy this. And instead of 20%, it's going to be 80%. A good practice here, if the size of one border is 20%, then the size of the other border should also be 20%. So we don't have 20% on the left and then 10% on our right. So we want to say 80. And with these three basic variables, we are going to also need some way of calculating the max value our offset can have. Because if we are at the end of the level, then we don't want the level to be moved and we see like a black screen or something, like there's nothing there, it's just black or completely white, whatever. We don't want to move the level any more than we can show. If there's nothing to show, then we're not going to move the level any further than that. So we need a actual max value that the level offset can be. And we're going to calculate that first by going private int level tiles wide. Here we're going to calculate how many tiles the entire level is in width, which we can get from a LoadSave dot get level data brackets 0 dot length. And this get level data is simply returning the current level, and it returns the level data. So we're simply getting the image width from this by going dot length like this. And with this we go private int max tiles offset, and this max tiles offset will be the offset from how many tiles we can actually see. So if we can see 20 tiles on our screen, but the level is 30 tiles in width, then we have 10 tiles to work with. So it's simply the amount of tiles we have minus what we can see, and this one will then be that result. So that will simply be stored in this one, which is equal to levels tiles wide minus game dot tiles in width. So we have the visible tiles and the total amount of tiles, and now we have a variable that stores that amount. And then the last one will simply be turning this max tiles offset into pixels, which will be max level offset x is equal to max tiles offset times game dot tile size. And that's all the variables we need for now. And to continue, we need some sort of method that's going to check the player position, and if the player position is beyond any of these borders, then we do something. But we need somewhere to have this method, and the best place is simply in our update method below the player update, and we're just going to call it something like CheckCloseToBorder. The name is okay, we know what it's going to do here. And first, in this method, we will need the player x, int player x, the current player x without any offsets or anything. And we're gonna retrieve it by recasting int, because I think we store player x in float. So player dot get hitbox dot x. It's a float, right? Yes, it's a float. So now we have the player x. And the way we can check whether or not the new player position, if we moved, is below 20% or higher than 80%, is to get a difference from the player x and the current level offset. So play int diff is equal to player x minus x level offset. If this difference is more than the right border, then we know that the player is beyond the right border and we need to move the level to the right. And if it's below the left border, then we need to move the level to the left. So we simply add a check down here. If diff is more than right border, the variable we added at the top here, then we do something. We say x level offset, the one we have, plus equals the difference minus right border. And let's do a quick example here to see how this math checks out. And we're going to use the example in the explanation. If the player is at 85 and the offset is 0, then the difference is 85. If the difference 85 here is more than the border and the border is 80, then we're going to go 85 minus 80 and apply this value, which will going to be 5 in this case, to offset. And just to check the next time, if we haven't moved, player is 85, offset is 5, the difference is 80. And 80 is not bigger than 80, so we don't enter this one. So yeah, this math checks out. For the right border, what about the left border? We may add another check here. Else if diff is less than left border, what are we going to do then? Well, we're going to do exactly the same, but instead of the right border, we're gonna do with the left border. So x level offset plus equals difference minus left border. So if the player x is 30, level offset is 15, difference is 15, then 15 is less than 20, 15 minus 20 is minus 5, and plus and minus becomes, well, minus, so it's going to be x level offset minus 5. So yeah, that checks out as well. And that's actually all we need to do to calculate the level offset. But remember, we also added three variables. But remember, we also added three variables to make sure that we don't have a level offset that is higher than what we possibly can have. And that's what we're gonna add below this. It's a simple, if it's bigger, then we set it to max. If it's smaller than 0, then we set it to 0. So if x level offset is more than max level offset, well, x level offset is equal to max level offset. And else if x level offset is less than 0, well, you guessed it, x level offset is equal to 0. So this just makes sure that the level offset doesn't get too high and less than 0, because then we can have some weird looking graphics. So yeah, that is all we need to do in this CheckCloseToBorder method. And now, what are we going to do with the level offset variable? How we're going to get it to the level manager and the player. And the simplest way I know of is to just pass it in our draw function here. So level manager draw g, and we also pass in x level offset. And to our player as well. And let's start with our level manager. Int level offset. And then this level offset we add to the x variable minus level offset. And we do the same for our player here. Render int level offset. And here is our x position minus level offset. And I think we are ready to give this a try. Let's see what happens. So I can run around, I can jump up here, perfect. All right, let's see what happens when I approaches the border. So the border is here somewhere, that would be 80%. And when I move towards it, the level follows, but it's white. What's going on? The player is sensing the level somehow. That's clear, but why aren't we seeing the level? And that has to do in our level manager. We are drawing the game based on the visible width for our game, which is not what we should have. So instead of games.tileSinWidth, we say level1.get level data, and then the bracket 0.length. So now we're actually drawing the entire size of the array, and let's give it a try now. So now let's see. Look, it's working. And we can now run to the right, and let's see what happens when we get to the edge. The player just stops, the level offset doesn't increase, which is good. And what happens if I run to the left? Beautiful. And what happens if I reach the end here? Yeah, the level offset doesn't decrease any further. Perfect. It's looking really good. We're also going to add two fixes. One bug fix and also one that I forgot to add in the previous episode. And the first one is the bug, which is when you're holding down A and D at the same time, you're not moving, but there's a running animation. And this was pointed out by Spencer Hammond in the comment section on YouTube. So thanks for pointing it out. Let's fix it real quick. And the way we're gonna fix it is by this section here. In our update position, in our player class, we're gonna comment this one out so we know how it used to look. First, we're gonna add a check if we are not in air. And just like before, we need to check if we are not left and also not right. If that's the case, then we want to return. We just add a return there. So it's the same as before, but this is only checking if neither of those is true. But we're also going to add a check if both of left and right is true, then we're also going to return. So we're just going to add brackets around our left and right here and add a or and do the same here, right and left. So here we're checking if both left and right is false or both right and left are true at the same time. Then we return. So if I run it now and I hold down left, right, both, and we can see that the animation is not happening even though I'm holding down both A and D. So that was the bug. Now let's add the feature that I forgot to add in the previous episode. And that has to do when you play the game and you press pause, the background is as it was before, but just a pause screen in the center, which is not really ideal. So in our playing class, in the draw method, if it's pause, we draw the overlay, but we're gonna add two brackets here. And if it's pause, then we're gonna draw a gray or a black background that has some alpha in it. So it means that it's darkened, but not completely black and not completely transparent. So g.set color, new color. And this color will have 0, 0, 0, meaning black, but it will also have a alpha value. Let's try 100 and see what that's going to do. And then of course we need something to draw with this new color. So g.fillRect 0, 0 starting, and then game.width and game.gameHeight. So it's gonna cover the entire screen, and let's see the result. So it's darkened, but we can make it a little bit more dark, so maybe 150. Yeah, this looks better. So now we have a little bit of a darkened area around the level, which is looking pretty nice. And there's actually one more thing we're going to add, and that's a background for our menu here. It's just blank, it's just white, it's boring. And actually, one of the people who followed this series came up with a pretty nice background, in my opinion, that we are going to use. And with his permission, we're going to add this as the background for our menu. And we're going to need a background for this menu anyway, so why not use one from the viewers themselves? And we're gonna add it to our menu. So just drag it, drop it in the rest folder, into our load and save. Let's just copy one of these strings. And let's call it menu background image. We already have one with the name menu background, so menu background image. And then we're gonna change the name to background menu. And it's going to be background menu, and we had this one menu background. You know what? Let's keep it. So yeah, just keep them separate. They have the same name, but remember to keep them separate. So to our game states, menu, and we're just gonna add another buffered image here, since we already have a background image name. What are we gonna call this one? Background image pink. And this background image pink is equal to LoadSave dot get sprite atlas load save menu background image. And in our draw method somewhere, we're gonna g.drawImage, and we're gonna use this one, background image pink 00 game.gamewidth, game.gameHeight null, and that should be that. So let's give it a try and see how it looks. That looks 10 times better. So yeah, thank you Hagen for using your background image. Before we go to the outro, I would like to announce that the channel got its first donation on the Buy Me a Coffee page. It's by a user named Frostnope. It makes me really glad that you find these videos useful, and also it's great that you would like to get back to coding again. So thank you once again. Alright my friends, that was it for today. I hope that you found it useful. If you have any questions or need help, check out the Discord server. And also, the code and assets can be found on GitHub or on my website as usual. Don't forget to hit the like button and also subscribe. If you would like to support my work, there's a link in the description below. Until the next time we see each other, take care now and have a wonderful day. Bye.